guys, as I promised, I will be teaching integration, and this is not a waste of time. It's actually, I can revise this way quicker. Anyway, let's start. The use of integration came when we needed an antiderivative trying to find the area of a plane. So we needed some kind of antiderivative to get the area that was bounded by this curve. So we came up with integration. So that is the origin of integration. Now let us look at a function. If d of f of x divided by d of x is equals to f of x. Notice this is capital and this is small. Then symbolically we can write integration of f of x dx is equals to f of x. However, you will already know that when we integrate this function to get the previous function that came by differentiating this function, we can also get something as plus c. Now the origin of this plus c basically comes from d of f of x plus, let's say, 2 by dx. We already know that this function and this function will be differentiated separately, so we'll get something like d of f of x plus d of 2 by d of x, which is nothing but same as f of x. So we get our original function back. So that is why we introduce a plus c when we integrate a function which is indefinitely, but that is we have not attached any limits to our integral. Integration of f of dx, this entire thing actually is known as the integrand. There are various formulas attached to integration, so but we will not look into that now because we don't have time. There are basic properties of integration, like if you multiply a function of f of x, then this is basically k times integration f of x, k times f of x integration dx. And also there's f of 1x plus minus f of 2 of x plus minus f of 3 of x, then that comes out to be integration f of 1 of x dx plus minus integration f of 2 of x dx plus minus. So that is basic story of integration. Now what I want to do is I want to discuss a question here. Let's try to understand this question. Integration of 1 plus x whole cube by root x dx. Now we can notice that this is a known algebraic function. Known as in sense that we can expand x cube, which is just a plus b whole cube. We know that formula, and then if we divide, then we can get something. So let us work on that. There is also other way to solve it. In indefinite integration you can get multiple answers. The plus c that you get will give you the various different answers, like when you get tan inverse, the plus c can be pi by 2, so you can also get cot inverse, something like that. Try to understand, but here we'll be dealing with standard method to solve this. So the standard method to solve this is simply expand this, which is 1 plus x cube plus 3x plus 3x squared dx. Notice how we can just divide each of the terms by root 1 by root x. So we can get just 1 by root x plus x cube by root x plus 3x by root x plus 3x square by root x dx. And now if we integrate this, and we can get individually all of them, and the answer comes out to be 2 times root x plus, I'm writing the final answer, it will be plus 2x 3 by 2 plus 6 by 5 x to the power 5 by 2 plus 2 by 7 x to the power 7 by 2. Do not forget plus c. Plus c is very important. Now let us look at another question that we will be solving. This is a really good question. This must be tried at least once. Sec square x cosec square x dx. Now, no such thing exists as standard integration. We do not learn anything standard. The closest thing that we get is sec x into tan x, but here we cannot get that. Obviously, maybe we can get that, but I don't know how to get that. So instead, why don't we isn't sec square 1 by cos square and cosec square is 1 by sin square? So let's just write it as 1 by cos square x into 1 by sin square x. And halfway into the video I realize I'm talking in English for no reason. I am so sorry, but I find it more comfortable to explain in English. Dx.